Welcome to the presentation of Quantum Eraser from Tony in Grace Group. At the beginning of this presentation, I want to raise a question, that is, what is wave-particle duality? Before I answer this question, I want to record you a very famous experiment, which is the double-slit experiment. In this experiment, we have a light source passing light through two separate slits. The final result of this is that this setup provides an interference pattern on the final optical screen. And the interference pattern is a property of wave. So this experiment actually shows that the wave has the light has the wave property. Here is another picture from Wikipedia shows this experiment. So the light source passed through the screen with two slits and has the interference pattern on the final optical screen. Now, what if I slightly modified this experiment? I add an actual block right after the screen with two slits. By doing this, we force that the light can only pass through one single slit at the same time. This actual block will block one slit at the same time, at one time. I can move this block up and down to choose which slit I block, but I would never let the two slits open at the same time. So with this setup, what will the final result be? The result is very astonishing. We return back to the classical particle pattern. This is the pattern just like we kick the single bore we kick the single bore into these two slits, and we will have this result. It is a very straightforward particle pattern. So what is the difference between the modified double slit experiment and the original one? The only difference is that in the new modified experiment, we force the particle to pass through one slit at a single time. It has no possibility that it pass through both slits at the same time. It can only pass one slit. So if we combine these two experiments, we conclude that the light has this property, the wave-particle duality. Before I jump into our own experiment, the quantum eraser, I want to introduce you another thing, which is the light polarization. The light has different polarization direction, and in 2D, we can decompose them into two orthogonal bases, which is the vertical polarization and the horizontal polarization. I also want to introduce you another optical experiment, which is named polarizer. The polarizer only let the light with a certain polarization direction pass. The bottom left is a vertical polarizer. It only let the vertically polarized light pass. All the other light will not pass this. So after this polarizer, you can only detect the vertical polarized light. This rule is same for the horizontal polarizer. So with this knowledge in our mind, I can introduce you our experiment setup. Here is a apparatus with three components. The left slit is a vertical polarizer. The right slit is a horizontal polarizer, and in the middle there is a thin needle. We then let a light source shoot light on this apparatus. At the center of this apparatus, we use a unpolarized laser light to do the experiment. So what we see on the final screen is a single dot with no interference. This is a particle light pattern because there's no interference. We can analog this into our modified double-slit experiment. After the unpolarized light passing through our apparatus, it it has only one possibility. The probability it has no probability for the light to pass through both left and right at the same time. It can only pass through either left or right because the left and right are two orthogonal polarizer. There's no chance for for the for the light to pass through both of them at the same time. We eliminate this possibility. Now I will introduce a third polarizer, which is 45-degree polarized to the vertical axis. With this polarizer, the, the result change. We get back the interference pattern. Intuitively, we claim the photon passed through the left and right slit simultaneously because now there's no evidence that it came from one particular side, and we can analog this back to the original double slit experiment. So this this 45-degree polarizer served as a eraser, which erased the information that it can only pass through one slit. It erased this information, change it back to the information, change it back that it might pass through both slit at the same time. But here's something more than that. And let me illustrate this experiment step by step. Now let's consider a single photon path just shoot right from the light source. At the very beginning, it's a waved particle light single photon. We don't know either it will behave as wave or particle because it is just passed out from the light source. After it passed through our first apparatus, it must pass either from left or right. So it is chosen to be the particle light photon because it chooses its own path. It has only possibility to pass through one side instead of both sides. Now its phase is encountered the third polarizer. After the third polarizer, what is the whether it is wave light or particle light, it depends on we can figure this out from the final result. And as I illustrated before, the final result we have the interference pattern. So we can conclude that after the third polarizer, it is a wave-like photon. And we can because of this interference pattern, we conclude that it is a wave-like photon. So the very astonishing fact is that we delay the choice. After it passing through our first apparatus, it chose itself to be a particle-like photon. But then, after it passing through this 45-degree polarized polarizer, it goes to the wave-like photon. We delayed this choice by adding a third polarizer, by adding a third 45-degree polarizer. In other words, you can also interpret this as the particle wave duality is always valid. It before it made its final choice, the photon always has the chance to change from particle light to wave light, or from wave light to particle light. Here, I want to acknowledge Professor Liang, who is the leader of our group, who, who is the PI of our group, and give me a lot of advice in making this presentation. And also Yupeng Wang, who is the who is the starter of this demo and made the first edition and presentation of this demo. And Oishik, who did a lot of discussion with us and give us a lot of suggestion of how to make this presentation. And finally, um, Mo Chen, an undergraduate student at Purdue University, who who suggests me how to who give me some suggestion about the slides and made some edit on our slides. And finally is the reference of the picture in this presentation. Um, Here's the end of the presentation. Thank you so much.